9.4 Introduction. So in this video, we're going to look at the radius of convergence and what that means in terms of calculus and series. So we know that series can converge to certain numbers, and we know actually how to evaluate those. But the question is, how do we find the radius of convergence for basically any function? So we know them for very specific ones because we've looked at Taylor series. But now we're going to look at very general series and just figure out where exactly do those converge or diverge, and for what x's they converge or diverge. So the first theorem that we're going to look at is called the nth term test for divergence. And if you ever think a series is going to diverge, this is a great test to show that, because it always works. So if you have any series of a sub n from n equals 1, n equals 2, really any n value to infinity, it diverges if the limit as n approaches infinity of a of n is not equal to 0 or does not exist. So if we get something and take the limit and you do not get 0 or get does not exist, then the series will diverge. And we can show that a series a sub n of non-negative number converges if it's compared term by term with a known convergent series. So if we can say one term is equal to another term, and the next term is equal to the next term, and so on, we can show that what's called by comparison that a series will converge. And we call this theorem the direct comparison test. Because what we're doing is we're comparing our more complicated series to a simpler, easier series to evaluate. So we're going to let the sequence a sub n be a series with no negative terms or non-negative terms. If that is true, then a sub n will converge if there is a convergent series c sub n, where a sub n is strictly less than or equal to c sub n. So what this part right here means is that each term, like the third term of a is smaller than the third term of c. The fourth term of a is smaller than the fourth term of c. And as long as the terms follow this rule, then the series a sub n will converge. On the other hand, if a sub n will diverge, if you can find a divergent series where the opposite is true. If I can find a divergent series where a sub n is strictly greater than or equal to d sub n. So the first term is bigger than the second, third term is bigger than the third, and so on, then it diverges. Another very important thing to note here is that L'Hopital's rule can be used when using any test for convergence. So we just learned about the nth term for divergence, and we just learned about the direct comparison test. If we need to take a derivative to use L'Hopital's rule, because we're letting it go to infinity, we can do that. Later on, when we learn other rules, we'll find out how useful that L'Hopital can really be.